Alright, so there's multiple ways of doing this. One way is the crisscross method. What charge does Mg get when it becomes an ion? Positive 1? Plus 1?
Yes, sir.
Mm-hmm. It's plus 2. It's in group 2A. All of them get plus 2. What does iodine get? Negative 1. So remember, this group is always plus 1, plus 2, plus 3. This could be plus 4, minus 3, minus 2, minus 1, 0. Then when I write this down, the 1 will come over here, and the 2 will come over here. And we don't write 1, so MgI2. Another way of getting this is we have a plus 2. How many negative 1s do I need to add to make this 0?
2.
So I add 1. 2 minus 1 is not 0, so I'll add another 1. 2 minus 1 is 0, so I needed 2 of them to counteract that. So this has to be MgI2. And another way is doing Lewis dot. Mg has 2 dots. Iodine has 7. So I can come over here and put a dot right here to finish that spot. But I need another one to get rid of this dot. So I ended up with two of them. So what about this one? Gallium with oxygen. Someone's beside Brent because I think you get it, Brent.
Would it be gallium 2 and oxygen 3?
Yes. Does everyone see why it is gallium 2, oxygen 3? So gallium gets a plus 3 charge. Oxygen gets a negative 2 charge. So if you're doing the crisscross method, the 3 is going to come to the oxygen. The 2 is going to come over here to the gallium and become Ga2O3. Or we can look at this more complicated one. Gallium plus 3 and oxygen negative 2. And we need these to sum 0. Well, the least common multiple of these is 6. So if I multiply this by 2, I get plus 6 here. And if I multiply this by 3, I get negative 6 here. Plus 6 and minus 6 cancel each other out. And John, keep your head up. Yeah, be quick. So if I have 2 of these, I get plus 6 charges. And if I get 3 of these, I get negative 6 charges. And they cancel each other out. So I need 2 of these and 3 of these. And again, you could do this graphically. Gallium has 3. Oxygen has 6. So that means we're going to need to come over here and add 1 right here. Add 1 right here. But we got 1 left over, so we need another oxygen. That comes over here, adds it to right here, but this one is missing a spot right here, so I need another gallium. Galliums have 3. Add it over here, but now I have 2 missing. So I'll come over here, add another oxygen. And these 2 holes can be filled up by this.
Does this cross method always work like that?
I'm about to do an example where if you're not careful, the crisscross method will mess you up. This is what. So this way is probably the best in ensuring you're right. But it's slow. There's a lot of drawing. This way is what I do when it's easy. For example, for this next example, I like trying this method first if it's easy. Like this one isn't easy. And then I try doing this one if this one doesn't work fast. This is balancing charges. This is the crisscross method. And this is the Lewis dot method. I never do the Lewis dot method as it's too slow.
Yeah, it seems like it would take forever to get.
Well, it helps my flow brain.
That's why I'm doing all three. Again, I don't use just one. I like doing the balancing charges method. So let's do calcium with oxygen.
Will be +2 calcium and oxygen -2.
So what would it make?
Sir, you want it to be? It'd be Ca1 and O.
We don't write ones. So if we do the crisscross method, Ca is 2 plus and O is 2 negative, or +2 and -2. So when you crisscross, this is where crisscross can get you mistake. You put the 2 on the oxygen, and then you put this 2 on this. But you have to realize these can be divided by 2 and get CaO. This is why I always start with balancing charges. Does these charges cancel each other out?
Yes.
Then we know it's a 1-to-1 ratio. We know it's a 1-to-1 ratio. Does these cancel each other out? This one and that one? No, we need twice as many iodine to cancel out this +2. So I usually start with the balancing charges method for this one and these two cases. If these are the same charges but opposite in sign, it's 1-to-1. It won't have any numbers on the bottom. However, if they have different charges, then I try doing crisscross. So let's do potassium with nitrogen.
Well, potassium is +1 and I put it -3.
So one beside Michael.
Take 3 potassium.
So one besides Michael. Tell me what it would be. Besides Michael and Brett. Thomas, what would it be? You don't need it. We've already given you everything from the periodic table you need. Elena, what would it be?
I don't know.
I can do it.
Camera.
Me?
Yeah, what would it be?
Oh, I'm still trying to figure it out.
Okay, K3 and
So it would be K3N. Again, if you do the crisscross method, basically if these numbers are the same, I prefer the balancing charges method. If they have the same charge but opposite sign, it's a 1-to-1 method. So crisscross method, we're going to put this imaginary 1 on here. You don't actually write it. But the 3 is going to come over here. If you wanted to put the 1 here, just remember you don't put it on your final answer. So on your final answer, you omit 1s.
will you take off? We have to do it.
Yes.
How much do you take off?
Saying that's wrong. Water is not H2O1. by convention, we don't write it.
This is gonna rip me.
So doing the balance and charges, we have 3 negative charges. That means we need 3 positive charges. So there's a positive charge, here's a positive charge, and here's a positive charge. We now have 3 positive charges for 3 negative charges. So we should end up with 3K and 1 N. And occasionally, I guess I was a little wrong. Occasionally, I will do, not for this one though. For example, I do use Lewis dot occasionally for things like have aluminum, for example. For example, let's do aluminum with chlorine. John, what would it make?
Aluminum is so. The AL. AL3.
Mm-hmm.
AlCl3.
So aluminum is +3.
I just wrote down what
Chlorine is -1. So crisscross, 3 is going to come to the chlorine. The 1 is going to come over here. We erase the 1. Or if we were trying to balance charges, we have 3 plus positive charges. And thus we need 3 negative charges. So there's a negative charge. We need another negative charge. And we need another negative charge. So now we have 3 negative charges. And for this problem, I would also think about Lewis dot. I know aluminum has 3 valence electrons, and each chlorine only wants 1. So that means this aluminum is going to have to give up. It can only give 1 dot for each chlorine, so it needs a chlorine for every single dot. Because chlorines can only take 1 electron. Not before spring break, so y'all have to come back, be ready for it.
Can we not do anything tomorrow? Please?
Nah, we're doing stuff.
Oh, man. Stay for spring break. Call of Duty. I'm gonna go home and show you. That's the only way she could have the projector. I said, bring my. I have a projector at the house. Dude, we can hook it in the gym. Because she said we couldn't. The principal said that we couldn't hook it up to any of the teachers' stuff. So if we brought our own projector, we could just play it. Because I have my own projector in my closet, but I never use it. I can just bring it and tie it to a string. Or just set it on the floor. Like, that's a movie this video. Dude, I'm gonna leave my Xbox in this person, and then I'll bring it, and I'll bring my projector once. Get that.
Alright, question. Is this actually Ionic?
No. It's not valid.
Is this Ionic or not Ionic?
Which two is? It's iconic. Oh, wait. Hey. Stop it. I'm assuming no. No, sir. It's no. It's not over 1.7. It's no.
So this is 1.5 because aluminum is 1.5. Chlorine is 3.0. So 3 minus 1.5 is 1.5. So it's not ionic. What do you mean?
Yeah, which one looking at the top and bottom one?
Did you not hear yesterday what I said to do?
Yeah,
And I
but here-
specifically said which one you should use.
The bottom?
The bottom one.
The top one is for chemistry class. The bottom one is for IPC.
I slept all day yesterday, okay? So I have an excuse.
How did it lose there?
So technically, this formula doesn't work. Y'all quit it.
So,
One of you guys had to be an accident.
you want to go to
Y'all quit talking. Um, I'm gonna write y'all up.
Yes, sir. We'll be quiet.
Let's do a weird one. NaH. What ions does it have?
It says plus one plus wait, no. Yeah. Plus one, plus one.
So what two ions does it have?
3.1 and 0.1?
What's an ion?
I have no idea. Ah.
No, it's an element or a molecule that has a charge. So where are the two ions? Where's the cation? Which is the cation?
The cat's the name.
Mm-mm. I told you how to remember which one's positive and which one's negative. Yeah, because if you put on a number line, A becomes before C. So anion would be negative, cation, if you alphabetize it.
So anion?
So cation is the positive ion. So what's the positive ion?
Yeah.
What is the positive cation in NaH? That's an element. What is the ion?
Plus one. But they're both plus.
Plus one is just a number or charge.
I'm confused.
Na plus 1. No, y'all said plus 1, y'all said Na, but y'all did not say it together.
But you.
So, what is the anon?
H plus one? But they're both plus one.
No, you can't have almost plus 1. So, the sum of charges has to equal 0. This is a compound.
Well, then NA is going to be like 5.
Remember, hydrogen can become H plus 1 or H minus 1. It's almost always plus 1. This is one of the very, very few exceptions.
So hydrogen is the only one that can go from A plus 1 or 2 minus 1. I'm confused.
Technically, though, the correct answer for you guys should have been not ionic. It has no ions. Because hydrogen is 2.1, sodium is 0.9.
That's good.
So that would make it, what, 1.2?
Yes. I thought we were adding.
Let's see.
I'm passing.
Let's see if this is actually an exception. Because I'm not for sure if this value is only for the H plus.
I picked up.
Okay, it's for some reason this is considered ionic. Why?
Wait, why is it?
Yeah, that's a good question.
That's the question.
Again, this one is one of the exceptions where hydrogen.
Because nowadays you can be anything you ever want to be. So
I'm thinking 90.
yeah.
That's Carl Grace. Yeah, I did 9/11. Like in
And solar. Thomas something.
Give me 100.
Well, Thomas. Absolutely.
Yeah, so this is a compound that's just an exception to the EN rule. It's because hydrogen, whenever it is. Anyway, I wouldn't ask y'all any of the exceptions, other than you need to know that hydrogen occasionally becomes -1.
So why?
Huh? I've already explained that.
I've been charting 32 times in this class.
But would there ever be a thing like that with hydrogen
You know,
and sodium?
Yeah, this is a real chemical.
What about like hydrogen and lithium?
Yeah, there's lithium hydride.
Would there be like those? What? Lithium hydride?
Yep, that's what it's called.
No.
Remember, whenever it becomes an anion, we change the name to IDE ending.
I have another question.
Hmm.
How long will we let those sit? This sugar cane.
I'm going to most definitely drain them all before spring break, and then over spring break, I think it'll take about a week to dry.
Have you graded our tests?
Yeah.
Can we see our score? Or can I see my score?
I mean, yeah.
Kim, I help you drain them.
No.
Did I?
I'm doing it very slowly because I'm pouring it down the sink,
Oh.
and I'm dumping a whole bunch of water behind it so that it doesn't crystallize in the sinks and mess up the pipes. That's the reason why it's taking so long, is I'm only doing about 2 or 3 of them at a time. What I should probably do is get a big bucket, pour it into the bucket, and then take the bucket outside.
Dude, go outside of a big old crystal.
It's so exciting when I get them.
Oh, they won't be done until lunch.
Yeah, they won't be done until right after lunch. Anyway, we took it to lunch time.
I guess that's it for today.